Hello and welcome to our video presentation. I am Ahmet.
And I am Kutay. In this video, we will try to simply explain how to demonstrate sine cosine values on a unit circle.
So let's start without further ado. We will use our previously written code for this presentation, which you can see on the screen right now.
We started by defining our main variables, which are our angle variable alpha, our radius r, and the sine and cosine values of alpha, c, and s. R is equal to 1 because we will use a unit circle.
We then moved on to create a loop, which will let us animate a dot moving across the circumference of the unit circle. This loop has as many iterations as the number of alpha variables kept in our array. For this example, it is 100, but if we wanted to change it, it would be simple enough as changing the values alpha takes, changing the amount of values alpha takes, which is 100, as we see in this part of the code.
To make the changes easier to detect while the program runs, we use a pause command that will make the running program pause for 0.1 second in each iteration. Now we are ready to plot our unit circle. We use the subplot command here because we have three different plots, which will be the unit circle and the dot traveling across its circumference, the sine wave and the cosine wave.
We use the hold on command to retain the plot in the current axis so that new plots added to the axis do not delete the existing plot. Keeping in mind the plot that we want to retain is the unit circle, and the plots that we will add is the dot moving across it.
Here we defined a two-dimensional cylinder, which actually counts as a circle, because it lacks a third dimension. The circle has a radius of r, which will be 1 because it is a unit circle. It holds a total of 100 different values, each equally spaced.
We move on to plot this circle by using the plot command on its two dimensions. The axis command here lets us decide the maximum and minimum values of the x and y axis.
The animation of the point is done with this command. We assign a plot command to the sine and cosine values for this iteration. With each iteration, this command will also repeat, making a new point appear.
Plotting our sine and cosine waves pretty much works the same way. We use the subplot command, assigning their size and position.
Then we use the easyplot command, giving our new graphs their titles and also plotting them easily. We should note that x-axis here has the maximum value of 2 pi. The for loop ends after this command.
Now let us try running this program and seeing how it works. Let me arrange a few things first. I have ran into a few problems with the screen capturing program we have used, so I will change the marker size here before we begin. Otherwise, it will not work. We can see that it perfectly demonstrates the change rate of the sine and cosine functions.
Thank you for watching.
Thank you for watching.